Okay. Now we're going to look at um, prime factorization. Prime factorization. Prime factorization is a way of writing a number as the product of all prime numbers, where all the number factors of the number are prime numbers. The first form they talk about is the tree form. Way to do it is with the tree form. And these are some examples of prime numbers. Remember, prime numbers are only numbers where the factors are 1 in the number. Examples would be 2, 3, 5, 7. You can see the list here. You want to familiarize yourself with those. The first method they talk about to find all the prime factors is the factor tree method, where you start with any pair of numbers that are factors of a particular number, and you break it all the way down to all the leaves of the tree of prime numbers. So here we have 2 times 24, 2 times 12. So 2 is prime, 24 is not. They can be broken down. 2 times 12, 2 is prime, 12 is not. And 2 times 6, 2 is prime, 6 is not. They can be broken down, and you stop when all the leaves of the tree are prime numbers. It's not necessary to know all the factors of a particular number. Just know a pair. From there, you can break it down. So, in one instance, I saw that it ended in an 8, and 8 is an even number, so I know that 2 will go into it evenly. From there, it broke down. Next one here we have, suppose I know my multiplication tables well. I can break this down 6 times 8. 6 is not prime, so that breaks down to 2 times 3. And 8 breaks down to 2 times 4. 4 isn't prime, that breaks down to 2 times 2. In any case, all the leaves of the tree are prime. So we have 48 is the same thing as 2 times 2 times 2 times 2 times 3, or 2 to the 4th times 3. And that was number 48 there. Next one here is 84. And I see that it ends in a 2, an even number. So I know that 2 go into it, but just to show something different, I went ahead and added the digits together. 8 and 4 is 12, so I know that it's divisible by 3. So that 3 times something will go into it. So in this case, 3 times 28. Okay. So, and I know that 28 are factoring a 4 times 7. Even number, I could have done 2 times something, 2 times 14. 4 times 7 here. And 4 breaks into 2 times 2. So I have 2 times 2 times 3 times 7. Or 2 squared times 3 times 7. Next approach here they talk about is the lateral approach. Just we did it by multiplication. You can do the same thing with division. Each time choosing another prime, a higher prime number. So 2 would go into 120 60 times. I know that 2 would go into 60 30 times. And 2 would go into 30 15 times. 2 won't go into 15 evenly. So let me try the next prime. 3. 3 goes into 15 5 times, and 5 is a prime number. And so all the leaves of the tree now, they're all prime. So I have 2 times 2 times 2 times 3 times 5, or 2 to the third times 5. Let's look at another one. So now they're doing 48. So 2 goes into 48 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times, and 3 is a prime number, so I'll stop there. So now when I draw this out here, I know that 2 is prime, and I know that 3 is prime. So when I go to writing this out here, I have what, 48. It's going to be the same thing as 2 times 2 times 2 times 2 times 3, which is the same thing as 2 to the 4th power times 3. So I've shown you 2 different methods here. Now the next thing they talk about here is finding the least common denominator between 2 numbers. Okay. Now when you're looking for the least common denominator, you're looking for the smallest number that's divisible by both numbers. So in this case they have 10, and 10 is divisible by. So we can do that one there. So they do 10, and do the multiples of 10. 10, 20, 30, 40, 50. And then for 25, 25, 50, 75. So notice here that 50, is common to both. And that's the smallest one that is common to both. So that's the least common multiple here, between 10 and 25, is 50. So let's look at one here. So when they ask you to find the LCM between 15 and 20. Sometimes it's easier to do multiples of the large number till you find. So 20 will go into 20 one time, and then have 40. And then, so 15 won't go into 20 evenly. 15 will go into 40 evenly. 20, 40, 60. 15 will go into 60 4 times. So my LCD here is, LCM is 60. So I could have brought it out 15, 30, times 3 is 45, and times 4 would be 60. Sometimes it's helpful to do multiples of the large number first. Now, another way of doing it is using prime factors here. Okay. So, if you can do the prime factors between, let's say, 12 and 18. So I do the prime factorization for 12. I have 2 times 2 times 3. And for 18, I have 2 times 3 times 3. So the way this works is that the LCD is going to be the greatest occurrence of any one factor in any one factorization. So 2 times 3 times 3. So this will be the greatest occurrence of 2's in any one factorization times the greatest occurrence of 3's in any one factorization. So here I have 2 squared times 3, and here I have 2 times 3 squared. So my LCD is going to be the greatest occurrence of any one factor in any one factorization. So it'll be the greatest occurrence of 2's times the greatest occurrence of 3's. So my LCM is 2 squared times 3 squared. Let's look at some others here. So now we have 15 and 18. Its factored form is going to be 3 times 5. And 18 is going to be 2 times, what's that? 18 is 2 times 3 times 6 times 3. So that's going to be 3 times 5. And this is going to be 2 times 3 squared. So the rule is the greatest occurrence of 2's times the greatest occurrence of 3's times the greatest occurrence of 5's in any one factorization. So my LCM is going to be 2 times, the greatest occurrence of 2's is 1 time. The greatest occurrence of 3's is 2 times 3 squared times 5. So here you see it there. 2 times 3 times 3 times 5. And when we multiply this out, we end up with 90. And that's our LCD. Let's look at another one here. 50 and 100. So that's going to be what? 5 times 10. So I can say 5 times 5 is 25. 25 times 2. 5 times 5 is 25. Times 2 is 50. And we have 100. That could be 4 times 25. So I would have 2 times 2, which is 4, times 5 times 5, which is 4 times 25. This is the same thing as 2 times 5 squared. This is the same thing as 2 to the second power times 5 to the second power. So my LCD is going to be 2 squared times the greatest occurrence of 2's times the greatest occurrence of 5s, which is going to be 2 squared, which is equal to 100. That's the smallest number that both of them will go into it evenly. And that finishes 2.5.